Hello, I welcome you all to this another interesting screencast. We have two problems coming from the Engineering Mechanics and Dynamics 14th edition by RC Hibbeler. This video we're going to be solving the first problem 13-100. And in this problem we have been asked to determine the force of the arm on the ball. Okay. So we've been told that the ball is guided along the vertical circular path. So this is in the vertical plane. It's in the vertical plane. And been told what the circular path is described by the function r. And then if the arm has an angular velocity of 0.4 rads per second, and the angular acceleration of 0.8 rads per second squared at the instant theta equal to 30 degrees, we have been asked to determine the force of the arm. So let's draw the free body diagram. We are going to use the polar coordinates, right? So we do have the radial coordinates like so. Maybe we bring this a little bit down like so. So we have the radial coordinate like so. And we have the theta coordinates. Then we have the force from the arm, this one, and then we have the weight, okay, and then we have the normal force. So let's say we have this as our tangent line. Our tangent line, the point of contact of the ball. Let me extend this also the other side like so. Right. So let's say this point here, is our normal force. That's our normal force. And then we have this angle here. We're calling psi, right? And this is r, this is theta, and this psi is negative clockwise, is our alpha. And if this is our alpha, this here becomes 90 minus alpha, right? And then this one here becomes alpha, right? Okay, great. So this is our alpha also, this one here. Okay, all right. Then for this one, we do have here, we have this is theta here. So this one here is theta, right? And if this is theta, we expect this to be 90 minus theta, right? Right. So for now, we are going to call this here is our beta. Okay, and beta is equal to 90 minus theta. So this is our weight, this is F, and this is the normal force. So let's write down the components. So we'll have one component like so there, and then we'll have another component there. Okay, and then for the weight, we'll have one component there. Okay, and sorry, the weight is facing downwards. We'll have one component there like so, and another one like so. All right. So what do we have? So we said this here is the force F. This is F. Okay. So this one here is N cos alpha, and this one is N sine alpha. This one is W this is W cos alpha plus beta, right? And this one is this is sine alpha plus beta. This is cos alpha plus beta. Okay, so let's define these angles. Alpha plus beta is equal to 90 minus theta. Okay, and theta is equal to 30 degrees. Therefore, alpha plus beta will be equal to 90 minus 30, which is just equal to 60 degrees. And then alpha itself is equal to 90 minus psi, right? And we know that tan psi is just equal to r, the theta. And our r is equal to 2 rc, which is just a 0.4 cos theta. Therefore, the theta is just going to be equal to 0.8, that's minus sine theta. Then tan psi is just equal to 0.8 cos theta divided by minus 0.8 sine theta, and evaluating this at theta equal to 30 degrees. Therefore, our sine is just equal to cos 30 divided by sine 30. Tan inverse of that is a minus 60 degrees. Minus just simply means it's clockwise. This can also be written like so. Okay, like that. Great. Therefore, our alpha, which is just equal to 90 minus psi, is equal to 90 minus 60, which is just equal to 30. Alright. And then R again, so that we find the input, this is equal to 0.8 cos theta. Then our R dot is just equal to will just be equal to minus 0.8 theta dot sine theta. And then R double dot using product rule, this is just equal to minus 0.8 open bracket. We find the derivative of one while keeping the other one constant, and then we say plus theta dot squared cos theta. We are using product rule. Right. Then we know that our theta is equal to 30 degrees. Our theta dot is just equal to 0.4, and theta double dot is equal to 0.8. Therefore, R at theta equal to 30 degrees is just equal to 0.8 cos 30. Okay, this gives us a 0.6928. Then R dot at theta equal to 30 degrees, this is equal to minus 0.8 times theta dot, which is 0.4 sine 30. This is equal to minus 0.1600. So 0.8 times 0.4 times 0.5, 0.16. Then R double dot at theta equal to 30 degrees, this is equal to that's 0.8 by 0.5 plus 0.4 squared cos 30 by 0.8. So this we get a minus 0.4309. Okay. That's 0.4 squared cos 30 plus 0.8 by sine 30 and by 0.8. 4309. Okay, so we have done everything. Let's now find the values of the acceleration in the r and theta direction. These are the kinetic diagrams. We have a theta and we have a r. So our AR, as usual, these formulas usually will be given unless otherwise. Theta double dot is minus 0.4309 minus R, which is 0.6928 theta dot 0.4 squared. Therefore, AR is just going to be equal to minus 0.4309 minus 0.6928 by 0.4 squared. This is 0.5417. Okay, so minus 0.4309 minus our R is 0.6928 and theta dot squared 5417. And then we do have a theta, which is just R theta double dot plus 2R dot theta dot. This is equal to our R is 0.6928. Our theta double dot is 0.8 plus 2. R dot is minus 0.16 by theta dot, which is 0.4. Therefore, A theta just going to be equal to 0.6928 by 0.8 plus 2 by minus 0.16 by times 0.4. So this we get a 0.4262. Okay. So we have 4 by 0.16 by 0.4, okay, plus 0.8 by 0.6928, 0.4262. Alright, then we have summation. Which one do I start with? In this direction we have weight and force. In this direction we have weight and the normal force. Let me start with this direction, R, MAR. Therefore, we do have n cos alpha minus W cos alpha plus beta equal to MAR. And we do have n cos alpha, and our alpha is equal to 30 degrees minus W cos alpha plus beta. This is equal to 60 degrees. These are both cos, right? Then this is equal to the weight, which is 0.5 divided by the acceleration due to gravity in feet, the second square, then times AR, which is minus 0.5417. Okay. This one here, we do have the weight already, so we can plug it there, which is just 0.5. Therefore, n, making n subject to the formula, which we can do, is we just have 0.5 divided by 32.2 times 0.5417, okay, and plus 0.5 cos 60 divided by cos 30. This will get a 0.2790. Okay, so we have minus 0.5417 by 0.5 divided by 32.2 plus 0.5 cos 60 divided by cos 30, 2790. Then we do have, okay, then summation of forces in the theta direction equal to m a theta. Alright, in that direction we do have F plus n sin alpha minus W sin alpha plus beta equal to MA theta. And we do have F plus our n is 0.2790 sin alpha, which is a 30, minus the weight, which is 0.5 sin 60, and this is equal to 0.5 divided by 32.2 by a theta, which is a 0.4262. Working out this, we just get F is just equal to 0.5 divided by 32.2 times 4262 plus 0.5 sin 60 minus 0.2790 sin 30. So this gives us F is just equal to 0.3001 pounds. So our F, of course, is in that direction like so, and our N is in that direction like so. I guess this is about it. We found the value of N, and we've also found the value of F. I think this is about it, and I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.